Today we are working on 1.6 intermediate value theorem. This is a fairly brief lesson but very conceptual. We're dealing with the intermediate value theorem. This is the first one that we study because it's dependent only on limits. We don't need actual derivatives, which is the next big idea in calculus. The first thing we'll need to do is write out the intermediate value theorem. We're going to write this out and then we'll examine this piece by piece. So this is going to start with an if. Our theorems start with ifs. These are the conditions that must be true for the theorem to guarantee something. My first condition is if f of x is continuous. This is why we do intermediate value theorem after continuity. If it is continuous on the range from A to B, domain of A to B. And we can see this graphically, kind of draw this out as we go. Here's value A, and here's value B. And we'll just kind of draw a little continuous function here. Okay, so here is my continuous function, continuous here from A to B. If my function is continuous on A to B, and I'm going to write this nice and big, and, so also if, it must be both. F of A is less than Y is less than F of B. And this is what our notes say. I like to write this a little bit differently. I like to say Y lies between F of A and F of B. And we're going to see this graphically. The reason why I use this verbiage instead is that it doesn't strictly need to be that F of A is greater than F of B or F of B is greater than F of A. And the notes that I have say each one. F of A is greater than Y is greater than F of B, or F of B is greater than Y is greater than F of A. But I think really the heart of it here is that Y must be between the values of F of A and F of B. And we'll see this on our graph, looking kind of, here's my function at A, this is F of A. And here's my function at B, this is kind of over here, right about here, F of B. And I'm assuming, for the sake of this argument, that I have some Y value that is between F of A and F of B, whatever their values may be. They could be positive, negative, F of B could be on top, but Y is between them instead of outside of one or the other. Then, this is my guarantee. If and then there exists at least one value C, x equals C, so C is some x value, that's what we're saying, on the range A to B exclusive. So we can draw this out here. I'm saying somewhere between A and B, there is some C. Okay, sure, there's some C. There's some C such that the value of the function at that x value C is equal to that Y. So somewhere at C, somewhere a C exists that gives me that Y value. So essentially I can draw out from that Y. And here is what that C value is. So that C, that x coordinate of C, whatever that number is, 8, 12, negative 3, exists for that Y. And this might seem kind of weird, and go, well, yeah, sure, it's in there. Well, we can determine this based on the continuity because it's continuous. If my function was not continuous, I could maybe draw it like this. Here's a discontinuous function, and then C would fail to exist such that I would get a f of C of y. This is my f of C. Okay? So only by being able to prove that a function is continuous can I prove that that value, whatever it may be, exists. And eventually we're going to use this in more complex theorems later in the course after we've investigated derivatives more. For each of these graphs, we're going to determine, is the theorem applicable for this graph on the intervals given? And these are the same graphs. And one thing that we're really going to find as we investigate here is that the theorem may or may not apply, and there may be some value, f of c, that equals y, and those can happen independently of each other. The only thing we know for sure is that if the theorem applies, then c such that f of c equals y will exist. So we're going to look at that here. This is the same graph, same function, everything's identical on the left and right here, but our first one asks, is there a value of c, that would be our x value, is there some x value between -5 and 2? And I'm just going to mark these portions here, -5 to 2, such that f of c, c was our x value, f of c is the y value at that point, equals 2. So where does my y value equal 2? That's here. Is there some place that the function's defined is basically I'm asking, and yes, I'm looking on this range from here to between -5, I find that my function is defined right here. That's about maybe -4.5. Yes, I'd say about -4.5. Roughly, I'd say that's a good estimate. Does the IVT guarantee that value's existence? Does the IVT guarantee it? Why or why not? For the IVT to be applicable, the function and its range must satisfy the two conditions. First condition, is the function continuous on the domain? Is the function, is f of x continuous on the interval -5 to 2? Well, looking at the interval -5 to 2, it's not continuous. I have this big jump discontinuity here. That is my jump discontinuity. So I'd say no, the function is not continuous. It is not continuous on that interval, on -5 to 2. Therefore, IVT does not apply, and this value, even though it exists, it is not guaranteed by the IVT. It is not guaranteed. No guaranteed, no money back guarantee. Buyer beware. Looking at this function, this graph again on the right, we are given a different domain of values from -1 to 5. Here's my -1. Here's my 5. And it's a little bit off on this graph, but we can assume due to the arrow here that this would continue on past the end of the graph. And first we're asked, is there a value of c, that's an x value, between -1 and 5, such that f of c, that's my y value, equals 2. So here's my 2, and I look all the way along from 1 all the way to 5. And there's no place that my function down here crosses a y value of 2. So no. No. No, there is no such value. Does the IVT guarantee that value? Does the intermediate or between value theorem guarantee such a value? Well, to determine if the IVT applies, we need to check two requirements. We looked at our first one on the left. Is f of x continuous on the interval? And that interval is -1 to 5. And looking at our graph, You can see if we start at -1 and move our way along, that yes, my function is continuous. Yes. All right, so with our last problem, it failed to meet that first condition. We didn't even bother with the second. But recall that our IVT has two parts, two conditions. This is condition 1, this is condition 2, and both must be true. Y must lie between f of A and f of B. So Y, that's my f of C here, does that lie between f of A and f of B? Well, what are my A and B? This is kind of the weird part. This is my A and my B. Well, what are my f of A and f of B? This is part 2. Does Y lie between f of A and f of B? Well, if A is -1 and B is 5, then f of A, or my function at -1, is about -0.5 here. And f of B, my function at 5, is about -3.5. So checking this, would I say that 2 is between -1.5, sorry, is between -0.5 and -3.5? Does that lie between? No. 2 is not between 0.5 and -3.5. Therefore, IVT does not apply, and there is no guarantee. Now in this case, even though it was not guaranteed, there's no guarantee, it did exist, but it was not guaranteed by the intermediate value theorem. In this case, it was not guaranteed and it didn't happen. It's kind of like, you might say, if you're carrying an umbrella, you won't get wet from the rain. So if it's raining and you're carrying an umbrella, you're guaranteed not to get wet. This is the special guarantee of our umbrella. It keeps you from getting wet. If you don't have the umbrella, do you get wet? It depends. Is it raining? If it's not raining, you still wouldn't get wet, even though you didn't have the guarantee from having the umbrella. Similarly, you might have a C exist even though the IVT does not apply. So it's important that you don't just skip straight to finding C, but that you first evaluate, does the intermediate value theorem even apply in that problem? Based on this, my two conditions are my function must be continuous. My function must be continuous on the interval from A to B. And my f of C must lie between f of A and f of B. In our previous examples, we looked at this graphically. Now we're going to see what this is like analytically. Now we want to read our instructions very carefully. There are several parts to this. The first, generally each time you find a verb, that's a part of the question. So the first is determine, does the IVT apply? And secondly, we need to state why or why not. Just because the IVT does not apply doesn't mean we're done. We need to state why it does not apply. Finally, if it does apply, then we need to find the value of C. Find the value of C. So these are the three parts of each question. I'm going to go ahead and do these in the same color. Determine, is the IVT applicable? So first I need to know, is my function continuous on the interval? So to determine that with this function without seeing the graph, we can look at this and recognize, well, what value would make this undefined? What would make it fail to be continuous? And looking at the denominator, if x plus 2 equaled 0, it would be undefined. Therefore, this is discontinuous at x equals negative 2. Is negative 2 on this interval? If it is, then I have a discontinuity in the interval. If it's not, then I don't care. All I care about is this interval. So if I were to graph these on a number line, 0, here's 3, here's negative 1, and here's negative 2. This is my discontinuity, but negative 1 to 3 is my function. So negative 1 to 3 is continuous. Everything else is good except negative 2. Negative 2 isn't on my interval, so I don't care. Yes, f of x is continuous on the interval from negative 1 to 3. Our second step is to determine, does f of c lie between f of a and f of b? Now this was kind of easy graphically. We could just look at it. Analytically, we need to find out what is f of a and f of b. And my interval gives me my a and my b. And to find f of a, I need to take the a and plug it into my function. So I'm going to go negative 1. We'll take our function. Minus 3 over plus 2. And we'll do this for f of b over here also. Minus 3 over plus 2. For f of a, or f of negative 1, I plug in negative 1. For f of b, or f of 3, I plug in the 3. So I get negative 4 over 1, or negative 4. This is my f of a. Over here, I get 0 over 5. 0 is my f of b. And they give me f of c, 2/3. Does 2/3 lie between 0, 0 over here, and negative 4? Oh, no, 2/3 is over here. So I would say no, IVT is in blue. No, IVT does not apply because f of c does not lie between f of a and f of b. Now when you're doing this on a quiz or a test, I will not take this answer. You will not receive credit for this unless you show that you found f of a and that you found f of b. You need to show that you found those analytically, or if you're working graphically, tell what they are in order to get credit for f of c does not lie between f of a and f of b. A random guess doesn't cut it. Actually work through the process. Number 2 asks us about the same function here, but on a different interval from negative 4 to 1. So first thing I need to do is determine, does the IVT apply? Number 1, does the IVT apply? And my first test is the function continuous? Is it continuous on the interval negative 4 to 1? To do that, I would look at the denominator, find out where is it discontinuous. We did this back here, but it's worth noting again. Where the denominator equals 0 will cause a discontinuity. So at x equals negative 2 is a discontinuity. Does negative 2 fall between negative 4 and 1? Yes, it does. Here's my negative 2. Here's my interval from -4 to 1. Therefore, my function is not continuous. F of x is not continuous on -4 to 1. F of x is not continuous on -4 to 1. Therefore, IVT does not apply. Now in this case, where IVT fails to apply because the function was not continuous, for a quiz or a test you must include what made it not continuous, where is it discontinuous. Showing where the discontinuity is would suffice, or explaining why it is discontinuous there. Simply guessing, oh, it's not continuous, but not showing how you determine that will earn no credit. So make sure you work through that properly. I'm leaving number 3 here as an extra credit. If you'd like to work this on your own or work with a partner, work through this and show all of your work, and this will be worth an extra 5% on the 1.5 quiz. Last 2 questions of the lesson. We're going to make sure we complete all 3 parts here, determine does the IVT apply? Does the IVT apply? State why or why not, and show that work. And then number 3, if it does apply, find the value C that's guaranteed by the theorem. So far, we've seen one where the IVT did not apply because the function was not continuous, and we saw one where the IVT did not apply because f of C did not lie between f of A and f of B. So those are the 2 things we need to check. Step 1 again is the function continuous? Is f of x continuous on the interval? And this interval is -1 to 1. So we want to look and see what discontinuities do we have, what would make this function undefined. That would be where my denominator would equal 0. So I have a discontinuity at 2. Does that discontinuity at 2 lie on my interval from -1 to 1? No, it does not. This is my interval. My discontinuity is over here, so my interval is continuous. So yes, my function is continuous. Number 2, does f of C lie between f of A and f of B? To do that, I need to find what is f of A and what is f of B, and check, does f of C, which is given as -1/2, does that lie between them? To find these f of A's and f of B's, we use the function, this is x over x minus 2, but we evaluate that at A and B. I'm going to do these in blue and green. A and B. A is -1, B is +1. Evaluating these, I get -1 over -3, or 1/3. Evaluating these, I get 1 over -1, or -1. Does -1/2 lie between them? Well, here's my 0, 1/3 is going to be up here, and -1 is down here, and -1/2 is here. So my interval, my range from f of A, this is actually f of B here, f of A, my -1/2 does lie on that interval. So yes, IVT applies, because f of x is continuous, and scroll this down a little, f of C lies between f of A and f of B. So we've now completed our first two steps. We have determined, does IVT apply? Yes. State why or why not. Because both conditions are met, and we show that work here and above. Then finally, because IVT applies, we're asked to find C. So we know that C in our function, f of C, equals negative 1/2. And we just need to solve this equation that we set up here. And we have a little, since we have a fraction on the left and a fraction on the right, we can cross multiply here. So on my left I have 2C equals, I'm going to use the negative on the top here, negative 1 times C minus 2. 2C equals negative C plus 2, distributing. 3C equals 2. C equals 2/3. Our intermediate steps here, distributing, add a C to each side, divide each side by 3. Gives me C equals 2/3. So when C is 2/3, that gives me my Y value, f of C, of negative 1/2, and that lies between f of A and f of B. Our last question can look a little bit intimidating. It's an exponential function, but we know that exponential functions are continuous on their domain, everywhere from negative infinity to infinity. So f of x is continuous everywhere because exponential functions are continuous on negative infinity to infinity. Part 1, done. Easy. Check. Correct. Then part 2 asks for our f of A and f of B. F of A, f of B, and it gives me f of C equals negative 4. Does this lie between? So let's find our function for A, that's 3, negative 1/2 to the negative 3 plus 3. And for f of B, the negative 1/2 to the negative, here's my B, 5 plus 3. And I simplify these. Negative 3 plus 3 is 0. Well, anything to the 0 power, which is just what's in the parentheses here, equals 1. Therefore, I get negative 1. Oh, we missed this minus 2. I missed this minus 2. Minus 2. Negative 1 minus 2 equals negative 3. There we go. And here this is minus 2. Negative 1/2 to the negative 5 plus 3 is negative 2. This one's a little bit trickier. I have now negative 1/2 to the negative 2. I can make that a positive exponent by taking the reciprocal. So it's going to be negative 2 to the positive 2. Negative 2 squared is 4 equals negative 6. So f of A is negative 3. F of B is negative 6. Does f of C, negative 4, lie between them? I like looking at the number line. Here's my 0, negative 6, and negative 3. Here's the area between. Does f of C, negative 4, lie between these? Yes, negative 4 would be in here. So yes, IVT applies. Because f of x is continuous everywhere. And f of C lies between f of a, and f of b. So IVT is applicable. Now we need to find C. I'm going to leave this one for a final plus 5% extra credit. This uses some logarithms. If you'd like to brush up on our logs, we haven't done those for a while, and go ahead and solve for C, we would set this up with our function f of x equals, we'd make that C. So f of C equals my function negative 1/2 to the negative C plus, plus 3, function minus 2, and I'm told that f of C equals negative 4. So you're going to solve this equation using your laws of logs for an additional 5% extra credit if you'd like it. And that's the end of our lesson on the intermediate value theorem.